Well, good morning, and I also give my welcome to 4G World here in Chicago, and thank you for your travel and your challenges in getting here. I would tell you that Malcolm Gladwell is a very popular author, and when you look at his books, The Tipping Point, The Blink, The Outliers, he causes you to think and look at the world through different lenses. And recently I came across a speech that he gave at the TED conference where his title was Choice, Happiness, and Spaghetti Sauce. And when I watched it, I thought I saw a lot of correlations with that and building 4G networks. And I know you're struggling with this illustration here, but when you think about the evolution of spaghetti sauce and the evolution of the wireless networks, there's a lot of commonalities. And one of his main points was, for years, when you did customer research on spaghetti sauce, you were worrying about things like the amount of salt, the amount of garlic, et cetera, and not thinking about outside the box in terms of what the customers might be interested in, and thus his research led to things like chunky spaghetti sauce. And so customers don't always verbalize what they want if they don't yet have that. And you see that market research in the 70s and 80s didn't ask about if customers wanted chunky vegetables in their spaghetti sauce until this researcher came across and asked that you didn't need to ask customers about what they wanted in perfect spaghetti sauce, but they wanted variety in terms of that spaghetti sauce, and that included chunky. And what that means to the 4G world is quite simply, when you're creating the perfect network, using our traditional metrics, it's not going to be enough for the future. What we need to be building is the perfect networks. It's plural for our customers. And to say it another way, most likely our customers want spaghetti sauce, chunky spaghetti sauce, as a choice. And they want choices in their networks. So let me give you some examples. There are a lot of us in this room that help sell a lot of devices that did 10 digits and a send and in button. And we sold them for a very long time, and over those years we added some features like color screens and cameras that added to the basic handset, but it was basically 10 digits and a send and in, and it didn't change very much. And it took companies from outside our traditional wireless space, outside from other industries that reached that Gladwell's tipping point to create things like the smartphone revolution. If you went purely by the market research, I don't think customers really talked about the fact that they wanted to watch video clips on those screens or have personal navigation devices or personal electronic assistance. And it's no different on the network side. AT&T researches, and that research of all the operators speak today, tell us basically similar things. What they're looking for is broad coverage, very solid voice calls, and higher throughputs. And that hasn't really changed over the last several years. And we've responded with our research in AT&T. For example, we've spent $90 billion over the last 5 years on both our wired and our wireless infrastructure, and that includes the purchase of spectrum and other acquisitions. We've built out our 4G network to cover a combined 275 million people. And 90% of our mobile data traffic is handled over enhanced backhaul or Ethernet to the cell. And in the year 2011, we made 150,000 different network improvements. We have plans to cover over 80% of the US population with LTE by the end of 2013. And over those same 5 years, from 2007 to 2011, network speeds have increased substantially, and our smartphone penetration is at record high levels, and our churn rate is at record low levels. And what does our latest research tell us? Well, consumers want broad coverage, very solid and reliable voice calls, and faster data networks. And as you can see, and probably suspect, I'm being just a little bit flippant about research in terms of finding out what customers want, because we know a great deal more about what our customers are doing and how they want to utilize our networks. And that has given us a very solid set of ideas for the 4G experience and what we are being asked to provide as we listen, ask those questions, and understand those needs of our consumers in implementing the right set of network technologies, plural. So let's look at a few charts that you're quite familiar with. This chart shows the growth of mobile broadband data over, which was 20,000% over those same 5 years, from 2007 to 2011. And that demand continues to rise. And as if you dig deeper in that race to deploy ever faster mobile data speeds, you need never to lose sight of how the customers are utilizing those networks, because it has significant ramifications on how you design them. This gives you this next chart gives you a high-level view of what customers are doing with that AT&T network. They're streaming, web browsing, and that makes up roughly 2/3 of the data utilization on our wireless networks today. And that's followed closely by smartphone apps and a smaller proportion going to email services. And every one of these require differences in terms of the bearer traffic, the latency requirements, and the signaling ramifications. This information may not come as a big surprise to many of you in regards to these industry trends. There have been many studies and surveys conducted over the last few years in terms of how consumers will be utilizing their devices for web browsing and video services consistently come out on top. But if we think back to that spaghetti sauce story and remember that for a minute, we've known for quite some time that customers want video, but in terms of thousands of them or tens of thousands of them, all in the very same venue, watching video capabilities or sending video capabilities, or using them when they're traveling at very high speeds in a car. Those things have significant ramifications in terms of the challenges of network operator as we build these networks. We've addressed these challenges in a number of different ways, including the deployment of distributed antenna systems. We've put these in places like AT&T Park in San Francisco, which has had a significant amount of traffic over the last few weeks. And we've helped out that's helped out our consumers with both coverage and capacity in those very large crowds. These DAS networks are made up of many antennas tuned to precisely match the areas of the building or the venue where we boost the service as needed. The AT&T DAS also helps address the exponential network traffic growth in those large venue areas and the hard-to-reach areas such as sporting and entertainment venues, hospitals, college campuses, airports, conference centers, and many, many more applications. We've even rolled out, literally, DAS on wheels. Our first venue was a major political convention earlier this year in Charlotte, North Carolina, where we were able to place a mobile head end in an AT&T truck and then place portable antennas around that area. And that provided us a very flexible approach for that venue that we needed to boost both coverage and capacity for a very short period of time. The results have been very impressive in terms of the pro sports venues where we've installed AT&T DAS over the last several years, more than doubling both the data capacity and the voice capacity. And AT&T is upgrading these DAS systems with LTE. Of course, our customers aren't just downloading videos, they're also uploading that content as well. Many customers use their smartphones as their primary camera or camcorder, and these days they love to upload their photos and videos to their social networking sites, and they usually like to do that when they're all gathered together at a football game or a concert and share that with tens of thousands of their closest friends. This is another example of how really understanding how that change in the usage pattern is also changing how we design and focus our networks. It turned out that a couple of AT&T engineers were keenly interested in this and addressed this issue through a new technology that we created utilizing a 5-beam, multi-beam antenna. This technology is an industry first in terms of network innovation, utilizing a wide antenna array in one row and using 5 narrow beams that covered roughly 20 degrees apart, and that was used to segment very large audiences in order to provide better coverage, and in this case, increased by more than 5 times the network traffic capacity that we could serve in that specific venue. We've used this further in other multi-beam scenarios up to 9 beams, and we've used it in various football stadiums across the country. And recently, we also used it at a major international comic convention in San Diego, where we installed these multi-beam antennas, and it helped us to be able to address nearly 5 terabytes of data sent across the network in the 5 days of that convention. Another success in our business is usually figuring out how to get closer to the customer. And AT&T is also utilizing that concept as we build our LTE network. One of the ways that we've done this is utilizing a distributed architecture where we've implemented our LTE network by putting the radio head at the top of the tower or the top of the rooftop instead of inside the cabinet with the baseband unit. Then we use fiber to connect that to the baseband unit itself. And this gives us the active radio components near the antenna, bringing the base station closer to the user, and thus thereby reducing the power consumption on that device, as well as boosting the performance of our 4G LTE network. Signals Research recently did an extensive study of our LTE network and said, all things being equal, placing the radio electronics at the top of the tower and thereby closer to the antenna mass has resulted in higher throughput and better coverage performance. Another area that we're focusing on is small cells or HETNet. I'm sure you've already heard quite a bit about that in yesterday's conference, as well as many of the talks today. You'll hear more and more about that. We've been an advocate of small cells for several years, and we've spent a lot of time with our vendors working on a strategy to deploy them. Today, small cells are no longer a new mobile technology on the horizon. They are an essential tool that we're beginning to utilize in our toolkit. In fact, Informa Telecom and Media said this summer that small cells will outnumber all macro cells in the 4th quarter of this year, and that femtos will outnumber the macro cells in the 1st quarter of next year. One variant of the small cell, as we refer to it, is a metro cell. They're less obtrusive and have lower power requirements than a traditional cell site and antennas, and they can often be posted on the sides of buildings or even on lampposts. These small cells are well suited for providing dedicated capacity in high-use urban hotspots such as hotel lobbies, restaurants, malls, train stations, airports, city streets, etc. Metro cells are also ideal for filling in those coverage holes in our macro network. AT&T has taken the lead in small cells within this industry group. Gordon Mansfield in my organization was recently named chairperson of the Small Cell Forum and is helping this group evolve its focus to more an operated-oriented approach to how to develop and build these solutions and solve some of the standardization of key aspects of the small cell technology worldwide. AT&T has begun our initial deployment of small cells in several venues, and we're in the process of doing our final field testing on those. Much of this small cell work to this point is primarily focused on our UMTS and HSPA Plus network, but we'll utilize that same architecture to add LTE and ultimately Wi-Fi. Although the early results of our small cell deployment are generally favorable, there's still a lot of work to be done when it comes to optimizing the small cells. Interference is a challenge, and that must be minimized. There are backhaul issues in terms of being able to provide an address to a telephone pole, et cetera, and provide that capability. And just because it's a smaller solution does not mean you've totally eliminated some of the zoning and the regulatory issues, and those must be solved with municipalities as well. One of the tools that we're using to help manage that heterogeneous network is a self-optimizing or self-organized network capabilities. SON is a very important tool for us as we improve our network management and efficiency, our coverage and capacity optimization, energy savage management, automatic parameter optimization, and intercell interference coordination. SON is a feature of the LTE standards and is also included in the 3GPP releases. SON is another example of building an intelligent network that adapts to the needs of your various customer utilization basis. And as a result, AT&T has been quite bullish on implementing SON capabilities on our network. To just give you one example of how it works through intelligent network management, SON is utilized to improve network quality by detecting when we have a specific cell site that is overloaded, and then working with those neighbor cell sites to adjust their power levels to enable us to offload that specific tower. Those towers then are instructed on how to expand their coverage so that the users could be reassigned to those other towers and thus reduce the overload on the initial tower. AT&T implemented our first SON solution in mid-2011, only a month after we found this in our AT&T Foundry, one of our innovation centers, and we became aware of this solution. Within several months, we deployed this across our wireless networks, and a nationwide deployment will be completed by the middle of this year, and that is helping us to improve the experience on our AT&T network as it continues to grow. Our initial deployments in California and Georgia have resulted in improvements of as much as 10% in terms of call retainability, 10% in throughput speeds, and 15% reduction in the tower overload scenarios that we were experiencing. Another important tool that we're driving towards in our 4G network is carrier aggregation. IP referred to that earlier in his discussion. It's an important tool considering the spectrum scenario here in the US. AT&T, for example, owns slices of spectrum in many different frequencies, in different blocks, in varying amounts, in different cities all over the country. So carrier aggregation gives us a method of managing these pieces of spectrum so our customers can get the best mobile broadband experience by providing them together on a common channel. Now, how does it work? In very simple terms, carrier aggregation enables the network to send data to the user over 2 or more frequency bands all at the same time, and this allows for increasing the data throughput rate to that user, and it provides us to allow that LTE base station to group those several very distinct channels into one logical channel, and thereby enabling very high peak traffic channel rates. If you look at this slide from Qualcomm, it shows that the supplemental downlink capabilities can increase those downlink speeds as well. Of course, this also introduces additional complexity for our handsets as well as our infrastructure, and that device complexity can rise dramatically depending on how you need to do the interband, contiguous, intra-band, non-contiguous, interband capabilities, and so we're working very closely with both the network and our handset providers in terms of introducing this capability. Another important advancement is the recent ruling that the FCC made on our WCS spectrum. You probably saw in the last few weeks that the FCC unanimously approved our joint proposal with SiriusXM, and that paves the way for AT&T to use that WCS spectrum for 4G LTE as well. This will allow us to deploy LTE in the WCS band while enabling the satellite radio services to be protected against interference. Of course, this will not happen overnight. We expect the LTE infrastructure to be operating in about 3 years, and so we are committed to work with both the standards bodies, our vendors, as we drive towards implementing this in both the infrastructure as well as the device capabilities. We appreciate the efforts of the FCC chairman, the commissioners, and the staff in their approval of this joint proposal. And we're also encouraged by the chairman's statements that this summer he still favors clearing spectrum for additional auctions that will also be exploring spectrum sharing ideas, and we look forward to being part of those conversations. In the meantime, AT&T is committed to obtain more spectrum in both public and private sources because there is no question that our nation continues to face a spectrum shortage. If you take a look at this next chart, it shows the potential usable spectrum that's in the pipeline. Compared to much of the rest of the world's top economies, the US has the least amount of potentially usable spectrum in the pipeline, but more subscribers and more minutes of use. We're very hopeful, given some of the recent activities that the FCC has taken on, and the FCC's National Broadband Plan was one of its first major policy documents that recognized the need for allocated that incremental spectrum. And we look forward to continuing to work with the FCC to free up new spectrum bands for mobile broadband utilization. AT&T and the U.S. wireless industry as a whole have done a great job in managing this explosive growth with the limited resources that we have available. But none of us, the carriers, the infrastructure vendors, or the government agencies, can afford to slow down at this crucial juncture in our industry. So while it's true that our customers can't always tell us exactly what they want, it's clear that they don't want the wireless industry to slow down in any way. And we need to continue to drive impressive work, innovation, new services, and technology advancements to meet those increased demands and provide them incredible devices and capabilities. Thank you for your time, and I'd be happy to answer a few questions.
Well, you certainly covered the landscape. I'm amazed how you were able to weave all those topics into one presentation.
Altogether.
Fantastic job. So what does it mean, personalization of 4G? I know it means spaghetti sauce.
Okay.
And I understand that it's some unique way of driving 4G into my life. So tell me a little about what that means for the network.
What that means for the network is that you can't just think about the postpaid or the prepaid segments. You need to think about all of the connected devices and what that means in terms of differences in bearer traffic, bearer to signaling traffic mix, the demand that it requires on some of your core network elements and how those varying. And so we do very, very focused forecasting and analysis so that we optimize our different components in both the radio access and the core to utilize that the most effective way. And then that also means that as we move towards a HETNet strategy and begin to introduce our QoS capabilities, that's going to require further enhancements in terms of how we assign, how we do handover scenarios, how we direct different customers and different use cases to different portions of our network.
So I think more than anyone else who's spoken so far, you exemplify why this event is called 4G World and why it's really about what the whole ecosystem of 4G is about. I think AT&T has taken all the elements of the 4G ecosystem and brought them to bear, not only in your network, but in your go-to-market strategy. But in terms of your network, HSPA Plus is still the foundation.
Correct.
And it's still part of that 4G experience.
Correct.
LTE is another layer above that, and in some geographic areas and for some customers, it will be the 4G experience they're seeking. How does Wi-Fi fit into that story? Because we view Wi-Fi to be part of 4G as well.
HSPA Plus now covers 275 million population, and we're continuing to expand that footprint. We announced in our most recent earnings that our LTE network covers 135 million pops, so a subset of that coverage. We also have a substantial number of Wi-Fi hotspots that we own and manage, and smart Wi-Fi capabilities on all the different device OS environments that allow you to utilize those without any action on your part other than allowing your Wi-Fi radio to be turned on. Over time, we are looking at other ways to enhance the Wi-Fi more significantly in terms of providing security over the interface, and then some QoS transparency between our macro network and those unlicensed network. So the fact that we own and operate those Wi-Fi venues will give us the opportunity to make that part of our overall bearer solution.
So you said we own, but you don't own. Some other part of AT&T owns that Wi-Fi network. Is that still allow you to optimize it as part of your 4G experience?
They're in the same organization I'm in.
Aha!
So yes.
So how big is that? How extensive is that so far?
We're at more than 100,000 locations and continuing to expand that.
Wow, impressive. That's very large coverage. Have any of the other U.S. operators stepped up into that Wi-Fi domain like AT&T?
In terms of building, not in the same way that we are.
Mm-hmm. And have they come to you and asked if they can use your network?
Some of them utilized it.
Ah, very interesting. I have a microphone here, and there's one over there. Does anybody else have a question? Grab that one, would you? One over.
Hi there. This is Josh Beck, Pacific Crest. I just wanted to ask, there's been some pretty well documented issues in terms of rolling out VoLTE and this kind of signaling storm. I just wanted to get your perspective on, how mature the ecosystem is and, how soon you think it could be ready for those type of services. Thanks.
We've been pretty consistent in terms of saying that VoLTE is more of a 2013 solution for us for our initial rollouts. In addition to optimizing your RF network, you also need to introduce the IMS core elements associated with that and have pretty seamless transition in terms of ubiquitous LTE coverage within that geographic area. You also have to migrate your E911 services and your SMS services to all IP as well. And so you've got to solve all of those solutions, and that's why we're targeting 2013. I frankly think the signaling, we've addressed that many times in terms of how we need to look at the utilization in very, very different ways. So I think we've addressed a lot of those already in preparation for that implementation.
I think Dr. Ashrafi from Metro PCS has a question.
All right.
Hi, Kris. Thanks for the presentation. Very, very interesting. I start with an announcement and then a question. We just recently announced...
Is it okay for Metro PCS to announce something during my... No.
No.
Go ahead.
We are launching RCS 5.0 tomorrow.
Right.
And as you know, one of the critical components of RCS is voice over Wi-Fi and video over Wi-Fi and being able to steer traffic from one access technology to another. And to that end, I would like to connect it with your self-organizing network. That is, if we have Wi-Fi as part of the heterogeneous network, how would self-organizing network would both work on the cellular side as well as Wi-Fi side to optimize the entire network?
So we are looking at both the ANDSF standard inside 3GPP as well as Wi-Fi Hotspot 2.0, the evolution of the Wi-Fi standards. And I kind of view those standards as overlapping circles, and there's still some gaps that we will need to fill in as an industry and also as an individual company to allow us to have those kinds of capabilities to deal with Wi-Fi as just another a bearer within our infrastructure. Now, whether that's an offering that we'd open up to other carriers, that's a different question. But we are definitely driving towards being able to use that on a more integrated basis.
And of course, on the Wi-Fi, you have best efforts.
Right.
And somehow, are you working towards putting quality of service into standardization in the Wi-Fi area?
Initially, we're looking at how do you deal with Wi-Fi in terms of just moving some applications, but not all applications because of that very QoS challenge. And so initially looking at that in terms of thinking it as an application level as opposed to the complete data traffic. And then over time, we would look at how we'd also introduce QoS.
Thank you.
By the way, I'm sure Kris would be happy to talk to you afterwards, but I have to get her off the stage now, or she's going to be doing Q&A for the rest of the day.
All right.
Thank you so
very
much, Kris.